All right, chapter 2. It says this. In this unit, we review powers with whole number exponents where the base is numerical. What do I mean numerical? What does that mean? Quick. Hurry up, what's numerical? Nobody knows what numerical is? A number, thank you. Where the whole base is a number. It's not fancy. You are in math class. You can just say number if in doubt. No. Okay. We extend these concepts into powers where the base is variable. The base, instead of just being numerical, the base is a variable. What's a variable? Okay. It can change. We represent things that can change with letters like X or Y or Z, right? Okay, and to where the exponents are integral and rational. In grade 9, you learned about things like 3 to the 5. By the way, we just did that with radicals, right? We had to make our little list, 3 to 2. Okay, so now we're going to learn in this unit, what about 3 to the 1/2? Is that such a thing? How about 3 to the negative 1/2? Is that allowed? Don't you want to know that? You're just dying to find out if you're allowed to do that and what that means? Okay, who kind of is curious? Come on, someone's curious. Is 9, okay, I'm going to do a little thing here for you, just to pique your interest. Okay, I'm going to tell you something here. Hold on. Do you know, see if you can figure out what the deal is. It's not so hard.
Becomes the first square root.
Do you already know what's going on?
Yes.
What do you know? What do you know about 9 to 1/2? So can you give me what this would be? What's the answer to this? 5. Oh. So you are telling me that this is the same thing as writing this. Yeah, you just learned something. Cool, huh? That easy. It's that easy. Okay. All right. So what about this one? How would I say this? What would this be the same as? The square root of
5 is the index.
Is it okay? Oh, 5 is the index. Ah, truly. It's true. It's true. So this one would be, there would be a radical. You put 27 in here, but this, instead of writing it like this, we could write it with a little 3 right there. Yeah, so cool. Okay, good. So now you're just so excited. In this lesson, we review numbers written as powers and exponent laws applied to powers with numerical bases and whole number exponents. We're going to say a lot of things like, if you're multiplying and the bases are the same, do what? Keep the base and add the exponents. Oh, you're brilliant. If you can just remember those things I taught you, right? If you're dividing and the bases are the same, what do? Keep the base and subtract the exponents. You guys are going to get those laws. They're going to get into your heads. You'll be hearing me speak in your minds. Okay. All right. So let's start here. First of all, let's talk about exponents. Let's just review. In mathematics, exponents are used as a short way to write repeated multiplication. You know what I'm saying? Like 2 to the 5, instead of going 2 times 2 times 2 times 2 times 2. By the way, at one point you probably thought that was a 10. Was there a time in your life when you thought 2 to the 5th power was 10? Probably. You had to learn a little bit. That's okay. All right, so instead of writing repeated multiplication like that, we can write it like this. That's not 6. No, it's not. What is 2 to the 3? Oh, you're so smart. Look how much you've learned, you know? Think about it. You've learned so much. Okay, they can also be used with variables, so don't be afraid of letters. Okay, so if I talked about the volume of this box, and I said the side links of it are A, instead of writing A times A times A, we could write A to the 3rd power. You on it? Moving on? Okay, good. So just a little bit of lingo or some words to learn. I said to my husband, I think sometimes people think I'm speaking Russian, right? Like, it's like trying to catch a word here or there, but you really don't understand the language. So this is the language of math. This little letter up here is called an exponent. You need to know that. That's a term. The exponent applies to what we call the base. Okay, the A is the base. And the whole thing is called the power. All right? All right, so really fast. State the base and the exponent. What's the base here? Quick.
4.
Okay, what's the exponent?
5.
What's the base? What's the exponent?
6.
What's the base? What's the exponent? Okay. Whew. I think if I just go fast enough, I can get it all done. This morning, my son just said to me, Mom, slow down. I said, what? He's like, you've been running upstairs, downstairs, doing dishes, putting stuff in the washing machine. He's like, just easy, Mom. I'm like, no. If I go fast enough, I can get this all done and curl my hair and get to school. I was a little late walking out the door, I have to say. Okay. Got it? Write it down. You know what I mean? Okay. Okay, let's go on. So here's this little, if you ever had to study your math, some people think reading is studying math. It's not. However, it's not necessarily bad. Here's this guy right here, he's really important. If you ever want to like get an overview of what's going on or the important points in your book, he's really important to go look at him. Like you should highlight him, okay? So always read those things, okay? So a number that multiplies a variable is called a coefficient. A number that multiplies the variable, Joey, is called the coefficient. All right? These are easy points to get, you guys. On your 9th grade test, I remember I asked you, what's the coefficient of the second term? What's the exponent of the third term? Remember me doing that stuff in 9th grade? Okay, these aren't, you just have to know the words. No math required, just know the definition. So it's literature. Actually, it's math literacy, right? You call it. So this is the coefficient. It's the number that multiplies the variable. Okay. So what's the coefficient? Quick.
8.
What is it over here?
-8.
Yeah, don't forget to take the negative. Always take the sign in front. Okay. What's the coefficient over here? No.
0.
No.
1.
No.
2.
Yes, there is one. A is not the coefficient. A is the what? The base.
7.
No, it's not 7.
8 over 7.
Thank you. Oh, because why? Because you take that fraction and you pull it apart. Remember we did this? Remember we did this just moments ago. Okay, a couple days ago. When we had this. How could you rewrite the square root of 7 over 3? Do you remember?
Yeah.
Go, Noah.
1/3 times 7.
Root 7. Remember doing that? I said you can pull them apart because this can be like over 1, right? Is that true? Okay, we can do the same thing over here. We can say 1/7, and we can multiply this by a to the 8 over 1 if you want to. You can pull it apart. Keep the 1s where they need to be, not a 7. It's a 1 over 7. Are you with me, Brooklyn? Okay, so the coefficient here is 1/7. Super important. Get it, Victor? Kind of? Pull it apart, put 1s in the other places. All right, it's hot. Here's that stop sign guy again. He says, note that written as repeated multiplication, 7p cubed is 7 times p times p times p. Right? P to the third is p. Yeah. Okay? This is. Okay? Now note this guy. Look, check out the difference. 7p in parentheses to the third means 7p times 7p times 7p. Do you see the difference? It's huge that you understand the difference between those two concepts right here. Get it, Ben? See the difference? Levi, you with me? When there's no parentheses, then the 3 only applies to the p, which means we have those. Then we could say, okay, this means 7 times, oh, so you mean I can multiply all those 7s together? Yes, you can. 343. And p times p times p, and we're just going to write it as p to the third power. Yeah? Catching on? Picking up what I'm laying down? All right. So, here we go. Write each of the following as repeated multiplication. Okay, which has to be repeated? What does the 4, look at the exponent, what does the 4 apply to? just the A, Malachi, not the 3. Not the 3, just the A. If I had to apply to the 3, you'd have to put brackets like that. Now, hey, look, now that 4 applies to the 3. But if there are no parentheses, then it doesn't. It only applies. So the 3 gets once, then there's A, and a B. Agreed? Those are all multiplied together. Write it down. Joey, pencil. Do you have a pencil? Fantastic. And you can put little time signs in between if you want to. Okay. How about this one over here? What gets repeated? The A and the B. So not the 3, just one time, but then A, B, A, B, A, B, A, B. Which, by the way, is the same as 3, A. Yeah? Hopefully it's not blowing your brain yet. You can do this, right? It's not so bad. Okay. How about letter B down here? Well, I'll wait. Ready? Letter B. How can I write that as repeated multiplication?
3A.
Right on. Okay. And D?
3A.
Uh-huh. Yeah. Okay. Which would be this? I'm just going to leave it. You can put all the 3's together and all the A's together and all the B's together. I'm not going to go there. We get it. All right. Okay. Ten to the third, you understand quite clearly, I hope by now, that that's 10 times 10 times 10, which is 1,000. And 3 to the 4 means 3 times 3 times 3 times 3. By the way, that's 9 times 9, get it? 81, just works quicker if you do it like that. And then negative 6 squared means, what's the base? What's the base? Negative 6, because it's in parentheses. So the negative 6 gets multiplied by itself, which gives you positive 36. Different than this question. Note the difference. Parentheses will kill you every time if you're not paying attention. Okay, in this case, what is the base? 6. The negative is not part of the base, because the only thing that is being squared is the 6. So you have to copy down the negative, you just write it down in front, and then you say 6 times 6, which turns out to be a negative 36. Totally opposite answer. Yes, Jason?
So if you go up to just a little bit, there was like a question that said, yeah, that one, the negative 3z to the 9th power.
Uh-huh.
Why did we say negative 3 for the coefficient?
Because a coefficient is different than a base. The base in this question here is z. The coefficient is the number that's multiplying it. Good question. Excellent. Okay. They want us to do all this. I think I've already told you this. Notice how we're cutting off a 0 here every time. See it? So we cut off a 0 here. Guess what this is?
1.
1. 10 to the 0 is 1. I taught you this last year. Anything to the 0 is 1. Can you remember that? Anything to the 0. I don't care if it's the funkiest thing in the world. 3 to the 0, guess what it is?
0.
1. 1. Anything to the 0 is 1. A to the 0. What's it going to be? 1. Okay. Whole big bracket like this. You had to do this. You have to give an answer to that when you were in 9th grade. What was the answer to that? 1. Anything to the 0 is 1. I mean anything. Okay. So that's a good reminder. So that should be an easy concept. So let's go down here and evaluate the following. Now let's be careful. What's the answer to part A here?
1.
What's the answer to part B?
1.
What's the answer to C?
Negative 4.
Oh, brilliant. This to the 9 to the 0 is not connected to the negative. 9 to the 0 is 1, but then there's a negative in front. How about letter D? Because this part is 1. See? Aren't you glad you had that harder book? That book I gave you for 9th grade? It taught you all this already. This is review now. You had that in ninth grade. So it's why I love that textbook, because it stretches you. Okay. Here with it. Anything to the 0 power is 1, and then do the rest of it. Okay. Here's the exponent laws. You've already had these. Let's remember. When you're multiplying, if the bases are the same, you keep the base and you add the exponents together. And here's why. Because 8 to the 3rd, you can write it out and repeat it. If you write that out and repeat it, you can see it's 8 to the 5. So are the bases the same?
Yeah.
So you could be written like this. So you keep the base and you add the exponents, which is 5, which is 3 plus 2. Okay, so the product law, this would be a to the power of what?
MS.
M plus n. Add the bases together. So if the bases are the same and you're multiplying, you keep that base and you add the exponents. All right, what happens when you divide? If the bases are the same, you keep the base and you subtract the exponents. Let me show you why I said this is like divide and conquer, plan risk. What? What does mn mean? If I write mn, what does that mean I'm doing to them? You're multiplying. We're going to get there. It's down here. So they have to be added. Good question, Gabe. Okay, now back to this. If we're dividing, it's like divide and conquer. You're going to fight, you're rolling the dice, and the guy who has the most armies wins. Anybody ever play Risk? Okay, a few of us. So here's what 8 to the 3rd looks like. 8 divided by, so on the bottom of your fraction is just 8. But we know that 8 divided by 8 is really the same thing as a 1. That's a 1. This 8 divided by 8 is also a 1. So we end up with 8 to the 1 power. See it? So how did we get there? Can I go from this concept to this concept without doing repeated multiplication? Yeah, just go 3, take away 2. So a to the 3rd divided by a to the 2, keep the base, subtract the exponents. So here we need to have a to the m minus n. By the way, it's always the top exponent subtracting the bottom exponent. Okay? Someone wants to ask, I know you do. Who's my math minds in here? Come on. Someone asked me if you have a negative exponent.
We have
Do you want to know? Can you have it? Thank you, Noah, for asking. What would happen if you had 8 to the 2 over 8 to the 3? You would have 8, if this rule is true, 2 minus 3 is 8. Sorry. 2 minus 3 is a negative 1, and can you have that? Yes, you can. Do you know what this turns out to be? Oh, and we are going to learn about that. Yes, we are.
Like that.
Now, exponents can be negative. All right, let's go on. What about 8 times 7 all to the power of 3? What can I do with that? Well, this is written out and repeated. This looks like that. Should write to that. So then we can group the 8s together. So we can group the 7s together as well and go 7 times 7 times 7, which turns out to be 8 to the 3rd and 7 to the 3rd. Follow the logic? So same thing happens if we have letters. AB to the 3rd power means AB, AB, AB. Group all the A's together, group all the B's together, and what you end up with is A to the 3rd, B to the 3rd. So if there are parentheses and there's an exponent outside, that exponent applies to everything inside. Okay, that's the rule you have to remember. Same thing occurs when we divide. I'm not going to go through all the steps, just over here at the end. A to the n over b to the n. Okay, that little n goes to everything inside the brackets. Just like I did when you were multiplying, the same thing happens when you're dividing. And last but not least, what do I call this?
Superpower.
Superpowers. It's a power of a power. Powers of powers are superpowers, and they are what? Multiplied together. So this is going to be 8 to the 6, but let's prove it. Well, A to the third squared doesn't, when you square something, mean you have to do whatever's inside twice by itself, like multiply it by itself 2 times, is what I mean. It does. So this becomes a to the third, a to the third. Well, that's the same as 8, 8, 8, 8, 8, 8. Oh, that's 8 to the 6. So when you have a power of a power, you multiply the powers together. Because if you wrote it out as repeated multiplication, you can see it all. So over here, we get a to the mn. There it is. Don't confuse it with the m plus n. Everything I wrote on the board there is review from 9th grade. Well, you might need that review. Might be good to review it, right? Okay, so let's go try using some. 3 to the 4 times 3 to the 2. What do you notice?
They're the same base.
Same base. What else do you notice? What are we doing?
Multiply.
You're multiplying. So if the bases are the same and you're multiplying, what do you do? Keep the base, and add the exponents. Yes. Okay, how about B? What do you got? Same base. We're dividing. So if the bases are the same and you're dividing, what do?
Subtract.
Keep the base. Your base better look like their base, by the way. It better look like this. -2 in the parentheses, just like theirs. You keep the base and you subtract the exponents. 5 taken away 3 is 2. All right, how about on C? What do you see? Powers of powers, which we call superpowers, which you do what? Multiply them together. So this becomes 5 to the 6. Okay, now I didn't actually finish these questions because it says, I need to read my directions. Use the exponent laws to simplify. Check, I did that. And then evaluate. That means find the value of it. I haven't done that yet. So I need to go do that. What is 3 to the 6th power? Say it again. 729. So y'all know how to do that on your calculator? 729, just type in 3 to the power of 6. All in favor say aye. Yes.
What's the power?
It's, what kind of calculator do you have? The little rafter, little carrot top thing. I don't want to call it carrot. Carrot. It's not carrot. It's like a carrot top. No ruffly thing on the top of the thing. You just find it. Jason, you good?
Yes.
Okay. How about, what is -2 to the 2? Now don't use your calculator for this. Let's use your brain. What is -2 squared? Tell me the sign and the value. Is it a negative? Should be a +4 because a negative times a negative is a positive. I'm teaching 8th graders that, right? Negative times negative is a positive. So you know this is a +4. Don't get that wrong. Okay, 5 to the 6. I have no idea. Huge. 25 times 100 times 25. 25 cubed. What is it?
5, 6, 2, 5.
5, 6, 1, 15, 6. 15, 6, 25. Yes.
My calculator says -4.
Aha.
I don't know why.
Right. Because you probably did this. Is that what you did? Yeah, that's exactly what you did. And there's a problem here. You have to put the -2 in brackets. Kale, I am so glad you said that because that was going to happen 17 times in this classroom. So if you don't put the brackets around it, you'll get it wrong. Okay. Next, we just got a couple things left and you can get to work. What are you going to do with this? Use the exponent laws to simplify now they're letters. No big deal. Let's go. A to the 4, A to the 3. A to the 7, because if the bases are the same, you keep the base and add the exponent. Okay, how about on B? X to the what?
7.
7.
This doesn't have a 1.
Oh, remember Ben? Has a little 1 on it. If you don't see an exponent, there's automatically a 1. So now we add those together and we get an x to the 7. Okay, how about C? You're multiplying. The bases are the same. Keep the base, add the exponents. All right, someone who hasn't answered a question yet. Letter D. A girl. Sariana. X to the 4, because if the bases are the same and you're dividing, keep the base, subtract the exponents, correct? We're subtracting. All right. Somebody on that line over there, far row. What are we gonna do on letter E? Victor, you got this.
For usefulness.
For with E,
E.
you like don't you divide or something?
Yep.
You divide the exponents and keep the y's.
We keep the y, and we don't actually divide the exponents. If we're dividing, we keep the base and subtract the exponents. So 10 take away 2 is 8. Do you know why we do that? Can you guys imagine why, hold 10 of them on the top? And then on the bottom, imagine why. Okay, I have to do it. I was hoping you wouldn't make me. Is that 10? Okay, let's pretend that's 10. And I would have YY on the bottom, correct? Then this would become a 1, and this one would become a 1. And I would have Y to the 8 left on the top. Okay, how about over here, F? How about this row, right here?
A12.
A to the 12, Y.
Super 4 times 3.
Yes, because superpowers, powers and powers multiply together. Good. All right. Kylie, your row. Y to the 5 to the 5. Y to the 25, same rule. Powers and powers are multiplied together. Okay. How about CC and Brooklyn back there? What do you got for X over Y all to the power of 9? X to the power of 9? Right on. Was it so hard? Okay, Jace, do you have a question?
I was gonna answer.
Oh, okay. All right. Ben and Paige. C over 4 to the 2. What would we do?
Okay, so it'd just be write down C
Uh-huh.
over 4,
Okay.
and then 2 to the power of both of them.
On both of them.
Yeah.
Correct. Yes. Now this could be written as C squared over 16. Anyone have a problem with that? We can do that, right? 4 squared is 16. Okay. J. We're on J. Joey or Levi? J. What do we got here? Anybody know?
6 ST.
Oh, AQ. Oh, dude, J like that.
Subtract J. Anybody know how to write this differently? Ashley, do you know?
J.
Yeah.
S T to the power 6.
No, that's what it is right now.
Yeah, but like, you don't have anything.
Yeah.
You have to write S to the 6 and T to the 6. The 6 applies to both. Follow?
It says simplified, but that seems less.
Yeah, I know. Just change it. Okay. K. Where are we at for K? Thomas and Miles over there. Give me K. 2 to the 5th and A to the 5th. Now we can work with 2 to the 5th. What's 2 to the 5th?
Oh.
No.
And
delete. CC, what is 2 to the 5th? How would you find it? And to do what? What would you put on your calculator? 2 to the power of 5, which is the same as doing what? Let's pretend I have a junky little old time calculator. How could I do it on my little calculator when I was little? 2 times 2 times 2 times 2 times 2, and that is not 10. That is 32. You with me, Abby? She's not. Woo, chill. Okay, we're on L. Last one. Who wants to do it?
Take the L.
All right, Malachi.
So the -3 needs to stay in brackets.
Oh, needs to stay in brackets.
4,
Okay.
and then P to the 4 and Q to the 4.
Okay. Is it important that the -3 stays in brackets? He said it was.
I second.
Second that. Okay, so what is your answer? What is -3 to the 4th power? Does anybody know? Without your calculator. First of all, tell me, is it positive or is it negative? You need to know.
Positive.
You know it's positive. Because it's a negative. Danny.
Yes.
Negative, 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 right? And if you have these two negatives, what do they make? When you multiply them.
Positive.
And when you have these two negatives, they make a what?
Positive.
Positive. Now positive, positive, make positive. There's no guy out here by himself to be extra and hanging out making the whole group negative, right? Don't hang out with those negative people, they make you all negative. Okay? Okay. So first of all, I know that negative 3 to the 4th is going to be a positive answer. So what is 3 to the 4th now? 81. Right on. So it's positive 81, P4, Q4. Okay. Good. Any questions? All right. You have some homework to do. Get out your little homework sheet. Find the questions that you need to do on there and begin.
So, can I go get some water?
Yeah.